Thanks. It's great to be here with all of you. Today I'm going to talk about publishing Jupyter notebooks with Quarto. Before I get into Quarto and publishing, I want to reflect a little bit on kind of the nature and purpose and value of Jupyter notebooks. And for those of you who are users of Jupyter notebooks or consumers of Jupyter notebooks, I think it's really instructive to read a paper that came out a couple years ago from Brian Granger and Fernando Perez, who sort of the two folks who created a lot of the modern Jupyter notebook ecosystem. And they talk about the breadth of things that Jupyter represents. Certainly it represents an interactive computing environment. It represents a file format. It represents a community and a set of projects. But they really, if you look at the title of the talk, they really focus on this idea of Jupyter helping humans to think and tell stories with code and data. And I think that this is really a profoundly important part of what Jupyter is. And if you think about the times just on the creative side, on the analytical side, when you write about what you're going to code, it actually changes what you're going to code. But clarifying what you're doing and why through writing affects the work. So that's kind of on the production side, but also on the side of the consumer of data products or analytics. Some of you may have seen the pamphlet that Edward Tufte wrote, which is sort of a takedown of this sort of reductive style of PowerPoint slides. But you could equally make the same comment about some dashboards where we're just spitting out very simple overviews of things outside of a lot of contextual information, a lot of assumptions, constraints, again, contextual information. And he points out that there are several very significant and important decisions, including the launch of the failed launch of the space shuttle, that if they had the benefit of a more rigorous presentation of analytics, it may not have happened. So the sort of idea of tools for data storytelling, of which Jupyter represents a huge component of, are really important. There's quite a bit of history to these tools, and in fact, they go all the way back to work on tech and literate programming, the idea of weaving together code and content, and they go all the way back to the first interactive notebooks. And so there's been lots of work that's gone on in literate programming, notebooks, Markdown systems, and this work has been happening in parallel, and I think in many ways in the last few years, it's coming together in a way that creates an incredibly compelling kind of tool chain and environment for doing storytelling with data. So now a little bit more about Quarto. I am the founder and CEO of Posit, which you probably haven't heard of. The company used to be called RStudio, which you may be more likely to have heard of. And at RStudio, I worked on the RStudio IDE. I worked on a system called R Markdown, and I worked on a bunch of R interfaces to other systems, including Python and Keras, TensorFlow, Spark. And so I worked on R Markdown quite a bit and started working on that actually over 10 years ago. And that was a similar kind of data storytelling, literate programming system. But unfortunately, that system was very successful, and we saw people benefit a lot from it, but it was sort of trapped in the R ecosystem. And so I was really not happy with that. And I really wanted to take a lot of the ideas we had developed there and sort of rewrite everything from the ground up to be multi-language and multi-engine and based on Jupyter. So that's kind of what the Quarto project represents. And this is a diagram. This is the kind of the basic mechanic of Quarto. I'll show this 2 or 3 times during the talk at different levels of depth and specificity. But fundamentally, you have a set of computations that are done in Jupyter. Those computations are transformed into Markdown. The Markdown is processed by a system called Pandoc, which we'll get into a little bit later. And out of that comes lots of different types of production quality output, including documents, presentations, web pages, or even things like websites, blogs, and books. So in this talk, I kind of want to cover the core ideas behind Quarto and the core motivations behind it, kind of what's significant about the system and what are the most important things to pay attention to. So we'll talk a little more about computational narratives. We'll talk about the specific requirements around technical communications. We'll talk about the value of semantic authoring, write once, publish everywhere. We'll get into a little bit of the debate, some of the debate around notebooks and what's good about them, what's bad about them, what are the mitigations for things that are not so good about them. and then a little bit about how the system works and how you can extend it. So we'll start with a little more about computational narratives. And I think Quarto represents a tool for doing computational narratives, and we've actually already talked about a bunch of these core requirements, Jupyter, technical contents, using Markdown, lots of different output formats. So there are actually a bunch of tools that do that, and in fact, NB-convert, which you may be familiar with if you're a Jupyter user, that's been around for a long, long time. But more recently, there are tools, including Quarto, as well as JupyterBook, Mist.js, that have do quite a bit more than NB-convert, support quite a bit more flexibility in output, support things like websites and books. So in this talk, I'm going to talk about this genre of tools through the lens of Quarto, but I think it's important to recognize that a lot of these tools do share a lot of features, and they're definitely all worth evaluating. All right, so back to our original mechanic, we'll get into a little more depth about how Quarto works. Quarto is invoked by saying render. You render a notebook. We start with a Jupyter notebook. Now that Jupyter notebook may have already been executed. You may have executed the cells interactively while you worked in the notebook, or you may want to re-execute all the cells for reproducibility or freshness of data. So you start with a notebook, either executed or not. I'll show this in a minute. You add a bunch of options to the notebook to condition what output is produced and specifically how it's produced. And then we do Quarto render, and we get the desired output format. So I want to talk, before I get into kind of the more depth about how all that works, I want to make a comment about Pandoc. That's a really important part of the chain. And Pandoc actually is a kind of universal document converter that's been around for almost 20 years. It was created by John McFarlane, who's one of the main, if not the main, kind of principal person in the Markdown community in terms of standardization. Pandoc represents Common Mark, which is the base standard, plus many extensions for technical writing. It actually supports dozens of output formats, just formats you've never heard of but are still nevertheless important, just about any format you could name. And for us, most importantly, it's very extensible. It's very hackable. You can write custom readers, custom writers, custom document transformers. And so for building advanced features, it's really unmatched as a platform. All right, so let's take a look at, again, the basic mechanic. This slide, I'll show you something you've seen before. It won't be particularly remarkable, but I wanted to sort of establish it as a baseline. Here's a notebook on the left that just reads some data and plots it. Just in JupyterLab, and here's the Quarto render of that notebook is essentially just an HTML transformation, straightforward, no options. Again, you've probably seen from NB-convert and other tools exactly this done before. So how do we enhance the presentation or condition the presentation of things? Well, we add options. So here I've added a YAML options block to the same notebook where I've said I want to use a different theme, I want to use a different highlight style, and I want to add a feature. I want to add commenting using the hypothesis engine to the document. So now when I render this document, you can see it's got obviously a different theme, different fonts, a different highlighting style, and then on the far right, you can see it's added a commenting bar. So that's the basic mechanic is you put a bunch of options in YAML, and there are literally, depending on the format, for PDFs, there's actually over 100 options. For HTML, there's dozens of options. So there's lots of options to condition things. I'm just sort of showing you, for example, here's some of them. So that's document level options. There's also cell level options. So here I'm kind of showing both. I'm going to put some document level options that condition how code is presented. And then on the cell, you can see I put a special comment using this hash pipe syntax to say I would like to make my figure cross-referenceable, and I want to use this as the caption. So now when I render this document, you can see the code is actually collapsed. You can see there's a code menu in the top. It's code tools menu up in the top right corner. And then you can see that the figure indeed does have a caption and it is indeed cross-referenceable. You can see the link, see figure 1. If I click that code menu, you'll see that there's a way for me to expand all the code or hide all the code. So this is just showing that as you layer in more options, the documents that you produce become kind of more and more interesting. And I think this underscores, hopefully you've seen a little bit, again, you've seen converting a notebook to a web page that's totally trivial, that's done by many, many, many tools, and it's done by NB-convert. But really, we're trying to go beyond that. We're trying to give you professional, stunningly good-looking production quality output and do it in a ton of different formats. So yes, web pages, but also Office documents, PDFs, presentations, aggregate formats like books and blogs, interfacing with content management systems. So that's really kind of what's distinct when you think about Quarto versus just a straightforward document conversion system. So a couple examples of that. Here we're going to say we'd like to convert the notebook to a Word doc just by saying format docx. We get the Word doc. And again, there's things in this Word doc that would be a little bit challenging to do just with Word, like code syntax highlighting, or even just placing two plots side by side in a panel. But that's done automatically by Quarto. Another example, we'll look at making a PDF. And one thing we'll get into this in a little bit as well, talking about some other features, but the optimum reading width for print is somewhere around 4.5 to 5 inches wide, which is not the whole page. And the optimum reading width for web is somewhere between 650 and 700 pixels. So actually, in most cases, it leaves room in the margins, and you would like to make use of the margins. So in this case, we're going to say we want to put our citations in the margin, and when we show a figure with two plots side by side, we actually want to use the entire page for it. We don't want to be limited to the width of the text. So you can see in making this PDF, we've got the citation in the margin as well as both the code and the plot kind of overflowing the main text column. So there are lots of things like this you can do for more sophisticated use of the entire page with some of these options. There's a whole, I will not actually be able to get to it in a lot of depth today, but there's a whole presentation system inside Quarto that has a lot of features. This presentation itself was created with Quarto. Here I'm just going to say I'm going to take my notebook and turn it into a slide deck and specify a logo and slide numbering. So you can see here, it's just going to, in the case I have two plots, they're placed side by side on the slide. There's a logo, and you can see the numbering. Now, this is for presenting data, but you also might want to. Some presentations we give in the technical environment are about code and trying to explain how code works. So here's another variation where we basically say we do want to show the code this time, and we actually want to highlight specific line numbers for explanation. So here you can see the slide has the code as well as the plot, and you can see the line 4 is highlighted. You can see in code line numbers, it's going to first highlight line 4, and when I advance the slide, it's actually going to highlight line 5. So this is very good when you want to explain code. There's a lot of tools for doing that. So far, I have shown you examples of single documents, but Quarto also has a project system which lets you create compound, sets of documents. And sets of documents might be collected together as a website, as a blog, as a book. And to create projects, you use this Quarto YAML file. That file defines a type, in this case website, some options for that type, in this case some simple navbar options, and then some common settings for documents produced within the project. Here we're saying use the Cosmo theme and apply the following CSS file to all of the content in the project. So some real-world examples of Quarto projects. This is the website for the FastAI Practical Deep Learning for Coders website. You can see it has the basics, but it also has some social metadata, has some links back to a GitHub repo, has some customization of the navbar and the sidebar. And you can see rendered. This is the website. You can see all the kind of navigation to all the lessons on the left, the table of contents on the right, the link back to GitHub, the navbar. So lots and lots of options for customizing how websites actually look and how navigation works inside them. Blogs are a special type of website. The YAML file looks somewhat similar to the FastAI one, has a bunch of social links and GitHub links, but it also has some customizations of the navbar and some additional customization for the Twitter card. And you can see this presents as a blog, which has a tiled display of different blog articles and navigable categories. And here's an example of a book. This again has some similarities, but it also has a cover image. It has a list of chapters, and you can see when the book is rendered, it has some different things. It has numbered chapters. It has numbered sections. It has when you see figure 3.6, you can actually do cross references across chapters using numbering. So different things going on with a book. And I should specifically mention for books, HTML books are very interesting and useful, but books actually can produce, there's actually 5 different book formats, including LaTeX, Word, EPUB, and ASCII doc. And ASCII doc is particularly useful for submitting books to O'Reilly or Manning. That's their base tool chains work off of ASCII Doc. So we're definitely seeing a lot of people write technical books with Quarto using these tools. Okay, let's talk a little bit about the particular requirements of technical communication. And I want to first reflect on the fact that the typical tools you use, Keynote or PowerPoint or Google Docs or Word, technical content is really an afterthought. You can see Google just announced code blocks in Google Docs like 3 or 4 months ago. So there's a lot of things you need to do when you present technical content. Code is one of the things. Figures is another thing. I've shown some examples of that. Citations and cross-references. But there's also math, and there's also diagrams, and there's also more sophisticated use of the page too, because you're not just presenting narrative. You're really trying to get people to understand things at a high level of depth and nuance. And so doing things with margins and using call-outs, all very important, all not very well supported by conventional document authoring systems. So as an example for source code presentation, here I want to explain some source code. And so you can see on the right, I actually have 1, 2, 3 parts of the source code that I want to explain, and those are linked to items at the bottom that explain them. The way you do that in Markdown is to just say, okay, this is the first thing I want to explain, and then you have a list below that says, here's the text that's associated with that. Similarly, the second thing, and similarly, the third thing. So this is just one example. There are many, there's an entire article about how to customize code block presentation in Quarto in terms of syntax highlighting, behaviors like copying code blocks, folding code annotation. There's lots and lots of things you can do, adding line numbers to make presentation of code really effective in Quarto documents. Mentioned diagrams. Probably a good number of people in this room are familiar with the fact that you can write diagrams using plain text. There's actually 2 major systems for that, or at least 2 systems supported by Quarto. One is GraphViz, which has been around for decades, and the other is Mermaid, which is a little more contemporary. Mermaid's actually supported natively on GitHub. So you define your diagram in text. You can see it's in a code block that looks similar to like a Python code block, and then the diagram is rendered by the rendering engine. This is actually quite a bit nicer way to write diagrams than clicking and dragging, many people have found. So Quarto natively supports diagrams. Equations, again, many of you have probably seen LaTeX equations. The LaTeX equations work very well in all formats, so they get typeset, whether they be typeset into a PDF or turn into MathML for Word docs or turn into MathJax for web presentation. Equations are handled very well also. And then we've shown a couple demonstrations of figures and cross-references. Here I'm going to create subfigures, which is a little bit of a variation. So I have 2 side-by-side figures that are subfigures. And when I render this, you can see the subfigures have captions. They can be referred to. You can see in the top right, figure 1B. And all this numbering and things of figures is done automatically. So that's also often quite important. Figure panels, figure cross-references, figure numbering for technical content. And then citations. I won't go into a lot of depth here other than to say that the Pandoc has very robust support for citations. And in fact, I had no idea that there were, I probably would have guessed there's a couple hundred ways to render citations. Turns out there's 10,000. So those are all supported by Pandoc. And then call-outs. You've seen these in content that you've consumed around the web. There's a kind of a simple Markdown syntax you can see on the left for call-outs. And these are supported in many, I think 8 or 9 different formats. The callouts end up getting rendered kind of in a way that looks natively good in all those different formats. And then I mentioned before use of margins. Again, sometimes you have a main narrative and you don't want to burden the main narrative with all kinds of ancillary information, but you still want the information available for those that care. So here I'm going to show placing content in the margin and then placing a figure in the margin and then also placing a table in the margin. You don't see everything in the notebook that drives that, but what you get at the end is, again, use of margin for a note and an equation and the use of the margin for a figure and a table. The other thing that happens is, again, we have this natural reading width that we want our documents to conform to, but sometimes we have visualizations that really want to be full bleed or take up the whole page. Here I have a panel of 4 plots. I really don't want that confined to the main content region. So here I can say I'd like this to go into a column. So the column could be screen or page or some kind of outset. Here I'm saying have it occupy the whole screen and have it be inset a little bit with shading. So here we can take full advantage of the width of the either printed or web page, but still keep our content at a comfortable reading width. So that's use of margins. Okay, a little more about this idea of semantic authoring. And I think I can illustrate what semantic authoring is in 2 ways. First, I can talk a little bit about what literal authoring is, which we're all familiar with, which is we write documents in the native editor and format for a given purpose. And many of us have probably used LaTeX. Many of us use Word or Google Docs, content management systems like Confluence, presentation tools. So literal authoring is kind of the most popular form of authoring, but it does come with some limitations. Foremost of which is that each of these ends up with their own proprietary format, and repurposing content across mediums, especially in an automated fashion, is quite time-consuming and challenging, and even inconsistent. These tools tend to not have a lot of support for technical content, and certainly don't support live code and its output. These are mostly content authoring tools. They're not computational tools. And therefore, there's not a really great way to automate and reproduce computationally derived content. So that's automate in terms of producing multiple types of content from the same source, and also producing content that's driven by computations. So if we look at semantic authoring, most all of you have probably seen Markdown. I don't need to explain what Markdown is, but that's really, Markdown is the quintessential example of semantic authoring, where you say, I want a heading, I want strong text, I want a code block, I want a block quote, and then some renderer will figure out exactly what that means in a given setting. Most critically, though, with semantic authoring, the document is actually parsed into what's called an AST, or an abstract syntax tree, that actually can be computed on. So this is actually the key to supporting all these features in Quarto and all these output formats, is that we're going to parse this. We're not dealing with a docx or HTML. We're dealing with this abstract representation of what a document is, and now we can implement all kinds of features on top of that and support all kinds of different output formats. And that's kind of the most important thing about how Quartos and Pandoc are able to do all the things they're able to do. So in the case of Jupyter, again, Jupyter is getting its executed content and Markdown cells over into Pandoc, which again, at the Pandoc layer, we translate it into this document AST. We use a bunch of transformations on the AST to implement all these features that we've talked about. And then finally, we render the final output from the AST. So that's kind of how semantic authoring works with Jupyter. Jupyter ultimately gets reduced into Markdown, and it goes into the rest of the system. And so Pandoc then actually supports, I'm not even showing you all the formats it supports. It supports dozens of output formats. The obvious ones you've heard of and think of, but also there's multiple types of presentation. There's multiple flavors of Markdown. There's multiple flavors of wikis that it can produce. And then there's other formats you may not have heard of. You may not have heard of JATS or ASCII doc, but those are really, really fundamentally important to a bunch of publishing pipelines. So by authoring semantically and getting all of our content into this universal form, we can produce content kind of in whatever form we need. And an example of that is kind of how you can use Quarto with content management systems. So many of you may be in companies or part of producing content that's managed by a system like Hugo or Docusaurus, or you produce content for Confluence. These are formats that actually were not built into Pandoc, but we were able to use the extensibility of Pandoc, custom writers and filters, to make it so you can transform notebooks and kind of Quarto Markdown into these formats. So here's an example. This is our same original Hello World notebook. And in this case, we've put the notebook inside a Hugo website, and it actually gets rendered in the sort of style of the Hugo website. Here we're creating Goldmark Markdown, which is the specific Markdown flavor that Hugo speaks. In the case of Docusaurus, they have their own flavor of Markdown called MDX Markdown. When we render the note, we stick our notebook inside the Docusaurus site, and we render it. It looks like Docusaurus. It uses their native flavor of Markdown, and then it uses their native rendering and theming and all that sort of thing. Similarly with Confluence, Confluence doesn't speak Markdown or really HTML. It speaks its own XML format. But because again we can compute on the document AST because it's we've authored in a universal fashion, we can take that same notebook and we can have it published into a Confluence wiki. And then I've alluded to this before. By being able to produce ASCII doc, we can put our books into the O'Reilly Atlas publishing system, which they then use to create print versions of books, web versions of books, EPUB versions of books. And similarly, Manning also uses ASCII doc. So this is just giving you an example. We added all these formats to Pandoc using the extensibility mechanisms. So whatever system or format you need to publish your notebooks or content in, it's almost certainly going to be possible. Okay, let's talk a little bit more about Jupyter Notebooks. And many of you have probably seen or heard of this talk from Joel Gruz, I don't like notebooks. And many of you have probably seen the Jeremy Howard's response to I like notebooks. So suffice to say, there's a lot of controversy about the nature of notebooks. Are they a good computing environment? Are they good for us? Are they bad for us? I think wherever you come down on all of that, I think it's hard to deny the fact that they are, certainly in terms of communicating about data, they are the coin of the realm. It's incredibly useful to have a standard format and container for code output and related narrative. This IPyNB format that is a universal publishing format. It has many different editors. You can publish both statically, like you see notebooks on GitHub. You can publish interactively, like when you publish a notebook to Kaggle or Colab. And they, again, also are a source of content for embedding in other documents. Everything that's in a notebook is programmatically addressable because it's a JSON file. So specifically, as an authoring tool, there are tons of different notebook front ends. I've just listed 5 of them, and they all interoperate with each other. That's incredibly useful. Some of the critique of notebooks has to do with the fact that they are just this JSON blob, and they're hard to diff. You have to use a specialized editor. You can't use a text editor. It's also important to note that there's a package called Jupyter-based, and there are actually no less than 10 different plain text formats for notebooks supported in Jupyter-based, 5 different Markdown formats that you can transform notebooks to and from, and 5 different versions of my notebook is a .py file. So I think, coalescing around this standard has even allowed us to create lots of really compelling plain text formats that benefit from the whole notebook ecosystem. You'll notice in the bottom left, we talk about Quarto Markdown. We have a variation of notebooks in the Quarto system that is a plain text file. And so the QMD file is essentially a plain text version of a notebook. So if you prefer to use your favorite text editor to edit, if you prefer to have all the cells always run in the same order, if you want your work to integrate well with version control, some of these fundamental problems get solved when you use the text-based representation of notebooks. I think there are pros and cons. I think there's different situations and contexts and constraints that would lead you to use an IPyNB versus QMD, use the best tool for the job in a given situation. But QMD is along with IPyNB, is very well supported in Quarto. Here I'm just going to run through sort of showing you that all the same things you see in a notebook are in the QMD file. I won't dwell on that. We have a VS Code extension that's very good at editing QMD files. There's also a really nice NeoVim mode that's available. And it does the things you'd expect: syntax highlighting and completion, lets you run things cell by cell. And you can see it has a lot of the sort of same idea of a notebook, but all in plain text. So this is just to make the point that using Jupyter as sort of this common point of standards for output and execution is really useful, and we can use IPyNB notebooks or not use IPyNB notebooks and still benefit from Jupyter. Another scenario is using notebooks as a content source. So this idea that when you've created an IPyNB file, it has figures and related code and explanation, or tables or other computations. And you may not want to publish that. There may be hundreds of lines of code. There may be research notes and things you don't want to publish, but you still want to extract the actual visualizations or other forms of data presentation. So we have a way to do that. So if you have a notebook, you can embed cells from the notebooks into a larger document. So here you can see this is a QMD file in VS Code that actually has this embed in it. So when I render this, it's actually going to pull the figure out of the notebook and stick it into the rendered document. You can see what that looks like. You can see the rendered document. You can see the figure that's been pulled out of the notebook. And actually, critically, there are links back to the notebook. So you can see at a global level, you can see these are the notebooks used by this article or report. And then at the figure level, here's the source for this figure. So in many cases, we want to have all this extra context. We want to have all this extra code. We certainly don't want to present it to all of our readers. Here's a way of allowing readers who want to know more or inspect more to be able to do that. And when I actually navigate to inside the notebook, you can see I get sort of an HTML representation of the notebook and all the code and narrative, and also the ability to download the notebook if I want to. We're actually working closely with folks from JupyterBook and Miss.js on a standard for doing this sort of thing for scientific publications. And the idea is to make notebooks actually a part of the scientific record and a part of peer review. So we're working hard to kind of drive a lot of standards around notebooks so that they become a standard part of the way people communicate and do science. Okay, a little bit under the hood, just a little bit about how the systems can be kind of extended and hacked. A little bit about how we interface with Jupyter kernels. We execute all code cells using Jupyter. You can use any Jupyter kernel you want. I've seen actually Bash kernel, C kernel, APL kernel all used. Python and Julia are the most widely used, and we've got some tricks to make sure. Sometimes this kernel startup time can be long, especially some versions of Julia can be over 30 seconds. And so we keep the kernel alive so that we get kind of interactive response times as we re-render documents. So fundamentally, we mostly use Jupyter kernels. It's important to note that execution engines are actually an extensibility point in Quarto. So there are other engines besides Jupyter that are possible. In fact, we have one other engine, which is the knitter engine, which gives us compatibility with R Markdown documents. But we may add other engines in the future. I know there are a couple of notebook systems in Julia that we've talked to folks about creating custom engines for. So we kind of want all of the infrastructure around document production, again, to be independent of language and even independent of execution system. Even so, Jupyter is the predominant execution system used now. There's a lot you can do about controlling the execution of cells. If you're authoring directly in JupyterLab or IPyNB, you can decide exactly when code execution occurs. You can execute something and then not execute it for another month. If it takes 3 hours to run, you want to leave it alone, that's fine. You can do sort of full top to bottom execution of QMD files, so you sort of have reproducibility and consistency. That does create the need for some caching, and there are a couple different strategies for caching, which I won't go into a lot of detail about now, but there's a Jupyter cache project, and then we have a feature called freeze. So there's different ways to make sure that if computations are expensive, they're not always in the way of content rendering. Really important part of the system is filters. We have that sort of abstract representation of the document that gets computed upon, and filters are what does the computing. And they can be used to do all kinds of things: generate content, modify content, remove content, produce target format specific output. So I'll just give you a brief example using the PanFlute library. This is a filter that simply takes any heading that is level 1 to 5 and bumps the heading level up by 1. You can see at the top, we render the notebook and we say we would like to use this filter. The full source code for the filter is below. And you can see the real work is being done by this one statement that checks for headings that are, again, levels 1 through 5 and bumps their heading level up. But you can imagine all sorts of things you might do with filters, including you can have embedded languages. That's how we implement the diagramming features that we showed before. Macro substitution, again, cross-reference and citations, image conversion, filtering, compression, transformation, advanced formatting, using the margins, callouts, lots of things you can do with filters. And that's really how we implement a lot of the Quarto features. But you can add your own filters. So any feature that you wish Quarto had, you can almost certainly implement it with a filter. So there's just some examples of filters that folks have created. Lightbox filter for doing lightbox treatments, chemistry-specific one, Molstar, ones for embedding QR codes, more fine-grained presentation of code. So lots and lots of examples of filters. You can actually write filters. There's a couple Python libraries for writing filters. And there's an embedded Lua interpreter if you want to write filters that have no dependencies. And then you can actually write filters in any language you want using a JSON representation of the AST. So lots of different ways to write filters. Filters are sort of part of our extension system. There's other types of extensions that are possible, which we talk about on our site. Filters being, I'd say, the principal one, but there's also shortcodes, which are sort of like content generating macros. You can write your own formats. And so, like, for example, the Hugo, Docosaurus, and Confluence formats, we used our custom format API to create those. People have created custom formats for journal articles. People have created custom formats for like themed versions of Reveal.js presentations that match like their sort of corporate look and theme. And you can create sort of different new types of projects and project templates. So lots of different things to do with extensions. So that's the example of like kind of hacking the system from within. What can you do to change the way the system behaves inside itself? But you can also integrate. It's an open source CLI tool, so you can integrate it with other tools and tool chains. One example of this is NBDev, which many of you have probably heard of, which is a tool for interactively developing Python packages within Jupyter. It automatically creates tests, publishes, does CI, and in version 2 of NBDev, it will publish a documentation website for your package using Quarto. So as an example of sort of embedding Quarto in a broader tool chain. So thank you.